Hello, and welcome to DETNET at IETF 110 online. I'm Lou Berger. We have with us Janos Farkas and our secretary, Ethan Grossman. This is our second session, and the information is posted as was as we talked about yesterday. This is an IETF meeting. I think you all know that, and most are familiar with the rules that govern our participation in our process. If you're not, please go look up the note well. Everything we say here, it becomes part of our public record, and it is being recorded. We're using MeetEcho. You're here with me, so of course you know that. And MeetEcho automatically handles our blue sheets, and it does have a chat channel. The Jabber is still there if you want to go directly into that. Note-taking, you've seen in chat, we're using code EMD. Please jump in and help us take notes and capture what is said. That's particularly important if you make a comment, whether it's in Jabber or in at the mic. I'd like to have that captured. Comments that are said in Jabber will be repeated in general. If for some reason you don't want it repeated, that's fine, but then don't add that to the minutes. As I mentioned yesterday, the tools page seems to be having a little bit of trouble, so you might want to go to Data Tracker. I'll point out that the Data Tracker now has the tools format HTML, which personally works much better for me, so you may wish to go there. We're in our second session. We have a joint session on Friday with that's being hosted by PALS. It's joint with MPLS and Spring, and it's really focused on the MPLS label stack and pseudo-wire related control word and OEM and how those things are going to progress. And there's lots of work going on in that area. So if you're interested in that topic, I suggest you join. The agenda has not changed since it was posted. We do have a reasonable amount of time for each slot. I'm going to try to go a little short, so leave even extra time for more discussion. As I mentioned yesterday, we've added a new step to our IPR disclosure process. Specifically, if you join as a contributor or as a co-author to a working group document, we ask that you make an IPR statement at that time. We reviewed the status of our drafts yesterday, so I'm not going to redo that today. If there's any questions, feel free to come on up to the mic or put it in chat. I should mention this, being asked for working group adoption, this OEM framework draft is the first one that's going to be presented. And so please pay attention. And we still no news on IETF 111. So with that, we're going to jump right in to OEM. Greg, just please make sure to say next.
Okay, ready. Okay, thank you. And let's go to the next slide. Okay, so we've been working on a document addressing the comments and discussion that we had since previous 109 meeting. And the structure is the same. What was updated is that we added the requirement section that previously was part of working group adopted document on OEM over MPLS data plane. And it included their section that discusses the use of hybrid OEM measurement methods that was part of OEM document in IP. Next. So originally we used their document that was spawned from raw OEM support, and we discussed it in 109. We received updates, and that reflects what we've done. I already mentioned that. No questions. Okay, we can go to the next slide. So what is a hybrid OEM? RFC 7799 defines active and passive. So the active uses the specifically constructed test packets to perform measurements, and passive is that it doesn't have any visible impact on the network. And one of the examples of the passive would be SNMP or probably netconf notification. There are different methods that been classified as passive. One of them is in a group of on-path telemetry collection, IEM, and alternate marking method. So the telemetry information can be, the process can be separated into two sub-processes. One is a trigger and originated, and the second is a collect and transport for the network analytics. IEM tracing uses two methods that characterize as end-to-end and hop-by-hop. In addition, for IEM tracing is defined direct export, which is every node that originates telemetry information exported to the collector separately, and another mode of collecting transporting is proposed and discussed in IPPM working group. It's a hybrid two-step. It is using the follow-up packet that follows the same path as a trigger packet using the same encapsulation and collects telemetry. Why we think it's important to discuss it? Because especially for the DETNET, where the network resources dedicated to DETNET service are scarce and precious, their method of collecting and transporting on-path telemetry is important. Because as you see, for IEM tracing, it embeds the telemetry information into data packet itself, into trigger packet. Whereas direct export and hybrid two-step can be transported out of band, even if they follows the same path, but using different class of service in the network for the hybrid two-step, or being sent out of band in terms of the DETNET using direct export. Next slide, please. And another important part that of the update to this draft is the list of the requirements. We didn't copy the list itself, so there are more requirements. We try to summarize that will fit in one slide. So I don't want to read them. You can look it up, and as part of their meeting materials, the slides are there. So what we emphasize is that each and every node in DETNET must be capable of acting as a source or addressee of OEM session, so act as a map. The second one, that's where we have some discussion among authors, and really appreciate your consideration and suggestion. So whether it's a should or a must, the DETNET OEM session originated from the central controller. Obviously, that's important, their network failure detection and IETF mechanisms that could be used. The protocols among them are BFD and ping and trace route. In-band requirement. Often there is some misunderstanding or misconception that active OEM is not necessarily in-band. By sharing the same encapsulation of their flow that is being monitored, active OEM is in-band. And so thus, we're able to do interpretation of their failure detection or performance metric collected and apply it to the network analytics. Another requirement is that OEM must support one-way measurement, whether it's a one-sided or two-sided. And in case of two-sided, so the results can be collected out of band. Path MTU discovery is important, so as packet replication, duplicate elimination, and order preservation function. And because this is a very DETNET specific, it's something that we're planning to take charge and have a proposal probably by the next meeting. And the protection switchover. So that's something that needs to be discussed in terms of whether it's an end-to-end protection or it's a local protection. And the next slide.
That this this slide and this section of the document is likely to get a lot of attention as we do adoption. And I'll just remind people that they can make their comment on the list and say they want it addressed as part of the working group process. It doesn't have to block adoption just because you disagree with one of these points. But it is good to express your view during adoption.
Thank you. What I wanted to stress is because now working group documents such as DETNET OEM in MPLS with MPLS data plane and another document with IP data plane, they referenced the requirements, and now they reference this document. So we, by moving this list of documents to its more logical place in an OEM framework in a DETNET, created a dependency. So it's really much appreciated consideration of adopting this work by their DETNET working group, and then progressing it further. Okay, thank you.
Thank you, Greg. And I like the approach, actually. And as you said, now this would be an OEM framework, a DETNET OEM framework, and to which the MPLS OEM and the IP OEM could refer to. This one would specify the common aspects for DETNET OEM.
Thank you.
Comments? Anyone want to come into line? We have a minute or two. I think it's really useful to get any objections to adopting this document. Normally, if we were in person, we would do our usual poll, but it's a little hard on Meet Echo. But getting objections is not. So please go ahead.
If I may, I don't know if DETNET uses this hands tool that is in Michiko.
I'd like to just ask people if they have objections, because if we do the tool and ask for objections, we don't know what the objection is. So I think we'd prefer to hear what the objection is, whether someone types it in Jabber or says it at a mic. I think those are good. Now, of course, we are going to do this on the list, so there's always an opportunity there. Personally, I actually have some technical comments on the document, but I don't think it blocks adoption. So I'll make those comments during the adoption call, and we'll address them during normal working group processing. But if someone has an objection, particularly a strong one, it'd be great to hear from them. All right, well, thank you very much for this work, and we should expect to see an adoption call on the list and hopefully get some good comments. Moving to next, I think we have control plane. Bring that up. Dirk, are you presenting? Are you out there?
Yes, I'm here. Sorry.
Yeah, please go ahead and just say next when you're ready.
I was just waiting for the slides to show. Yeah, if you go to the next one, please. Yeah, thanks. That's an update to the. We presented the first version of this in the 109 and in the interims meeting in December. We had discussions, in particular in the interims meeting, on what we intend to, the focus of the draft to be, and I highlighted the keywords here that are copied from the from the abstract, which means we are proposing changes to RSVP and SERV for a better alignment with with TSN. We called it RSVP -TSN in the document, and that means we're limiting the scope of the draft to those changes. We had a bit of discussion in the interim on whether or not this would have a broader scope to something like RSVP-DETNET, which we initially planned, but we kind of focused this down to the TSN part initially. But that doesn't limit us to maybe go for an accompanying exercise for other changes to RSVP, but we wanted to start with that. Go to the next draft, please. Next slide, please.
At the end or as you go?
Sorry, next slide, please. Have you changed the slide? I can't see an update.
It's the same slide. Same slide for me too. Now it's the next slide.
Yeah, thanks. Yeah, I think you jumped the structure slide. I think there was a slide in between though. Oh no, that's the one. Yeah, thanks.
Can you hear me?
Yeah, I can.
Oh, I had audio problems. I must have had a connection problem there for a moment. I apologize.
Okay. Thanks. No, yeah. We're on the right one. We're on the right one.
Okay. One question: do you want comments as we go, or do you want comments at end?
Yeah, that was the question I didn't really quite get. I'm fine either way. I heard something about end, but that must have been when you had audio problems.
Yeah. Okay. Let's just take it at the end. Keep going, please. Sorry.
Okay. Thanks. So we clarified the use cases as a change from the last version. We now present two use cases with what we call a hybrid DETNET over TSN aware customer network. The difference is that we have in one case a core network with RSVP support, and the other ones we don't. That's the difference in the use cases. Section 3 is now focused on the design rationale, which are the former sections 2.2.2.3.2.5. So we merged them into a new section. And then focus section 4 on the RSVP TSN proposal, which took the layer interactions revised from the previous version. So it's a revised part, but it's largely taken from the previous draft. And we also changed the API descriptions to align with the terminology, which was another comment we received. So in the structure, if you go to the next slide, please. Yeah, thanks. So section 2 are the use cases. Also there, we revised and aligned the terminology as a request. Design rationale, section 3, as I mentioned before. And then section 4 is the proposed design, which has the layer interaction, the interactions, the API descriptions, and the message formats will come in the next version. We didn't finish them in time for the deadline, so that's the last subsection of section 4. I don't know why the numbers went wrong. That's obviously not section 7 there, but never mind. That's at the end. If you go to the next slide, please. So we received feedback both in the 109, but also the interviews meeting here that we tried to address in the new version. So the scenario was the one, what type of scenario we had. That's why we revised the use case section to provide there hopefully a clearer example. We clarified the relation to the TSN specific data plane drafts by providing revised API descriptions in section 4. Also clarified the use of the flow information model by aligning the terminology in those API descriptions again, and also did a scrub. Hope that we caught most of the things where we had misalignments across the sections where we were diverging from the terminology. Thanks. Next one, please. So the next steps I'd like to do is to fill in the message formats and the protocol information, as I didn't get that done in time. And obviously would like to seek more input from the list, potential, which brings me to the last slide, if you can just jump to that one already, which means we would like to hear feedback, comments, potentially anybody who's happy to help us. Co-authors and contributions are very welcome. Thanks.
I think I got notification of David Black in the queue.
Yeah. If you saw the presentation on the Yang on Monday, does this draft intend to cover all of the data plane scenarios that were outlined in that Yang presentation?
No, we haven't reviewed that yet. I noticed that yesterday. I sent a note to my co-authors as well to have a good look at that. They couldn't make it to the meeting, so can't tell you.
Okay, let me suggest that the presentation material did a really nice job on covering all the various data planes that would work. It would be great if RSVP covered all of those. And as part of that, could I suggest you find an acronym other than TSN, which is going to create some bad implications about which data planes this applies to?
Okay, thanks. Fair point, yeah.
I'd like to follow up on that comment, even though I'm queue jumping in the blue. The document is focused on inner working of a DETNet RSVP with TSN. So unlike David, I think the title is appropriate because you really are limited there. But I'm going to go back to a comment that I believe we made at the last couple times that you've talked about this draft. Is we don't have a definition of what RSVP looks like for DETNet in general. And that's for all the use cases that David just talked about, where for IP, for MPLS, for aggregation, we don't know what that looks like. And there's a large body of work we can build on, in particular, the traffic engineering extensions to RSVP. And I note that you're not building on those, you're building on INSERV. So, what's your thought about addressing these base capabilities from the comment before, from David's comment, as well as from previous meetings?
Yeah, so when we discussed about how to move forward, because the comment, as you said, was made during the last meeting, to go for an RSVP DETNet, we found the access, at least for us, for the authors that we had, too large. So we honed it down to TSN. But I do agree, and that was the discussion we had in the last meeting, that there's a whole body of work to be done on DETNET view on RSVP, if you will. But it's probably that we didn't want to take that on, so hence we own ourselves down into TSN. But it's a little bit kind of avoiding the work. But I think it's maybe also starting the work. So we wanted to be concrete from the TSN angle, and can then maybe reopen, that body of work or that discussion once, we move forward, if you will, right? So that was a little bit our compromise in a way.
Okay. Well, with sort of chair hat on, my perspective is follow David Black's guidance.
Mm-hmm.
Balazs, you're in queue.
Yes, this is also what I wanted to highlight. So I think thank you very much for the update. Based on that, it is much more clear what was your focus with this draft. I would like to join the previous comments that the title might be misleading, because what you are focusing here is if RSVP is used for DETNET signaling and you are using REP for TSN signaling, how this control plane signaling can interact in a DETNET subnetwork scenario. So I think that is your use case, and this is pretty well described in the updated draft, so thanks for that. But I think also that this is something that must be highlighted in the title as well, that you have a special focus on a special scenario and not solving the control plane signaling for DETNET.
Yeah, that's a fair point. We left the title of the draft there, which probably wasn't the best thing to do, instead of reflecting the actual focus in the draft. So that one I do agree with. As I said, I mean, there is an interest to come back. I mean, I discussed this with my co-authors to look at the larger problem still of control plane signaling. But it would be. I see that as a body of work that probably goes beyond the competences that the three of us have. And that's why in the meantime, we would probably like to just stick to it. And we can just reflect that by narrowing also the scope clearly in the title and renaming the title. But certainly being interested in addressing the control plane signaling problem at some point as contributors.
Okay.
David?
The obvious question. If the draft scope is limited to if RSVP is used for DETNET, then this is how it works with TSN. Do the folks involved have running code for RSVP insert for DETNET?
Sorry, I didn't catch the question. I had an audio issue.
You have an implementation, even prototype, of RSVP int-serve for DETNET. I think your draft is assuming this works, and that's an interesting assumption.
Yes. Sorry, I again had a hiccup, drop out somewhere, but what I understood from the question is yes. That's what we do.
Okay, but do you have running code for RSVP for RSVP int-serve for DETNET?
Let me check that with my co-authors.
Yeah, I'd advise checking it, because I think that the questions lurking in here is it is a very convenient assumption, and it would be nice if it were true, that RSVP int-serve can work for DETNET. That really ought to be sanity checked somehow.
Yeah, thanks. That point.
Janos is in queue, so I'm guessing he's coming as a contributor. Please, Janos.
Yes, I have a similar concern, like the previous speaker said, that sort of the basis would be to figure out how RSVP works for DETNET on its own. And then we can think of integration with TSN. And without having the basic stuff, it's hard to see or hard to do the work, I think. I understand you want to narrow your focus, but still the basic, I'm afraid.
Yeah, I think Janos and I are about the same page. Not clear that RSVP int-serve for DETNET is the proverbial right thing to do, although I do understand the concern about massive expansion of scope of your work.
think we're running out of time, so we'll move on. I do think if you are looking at this work and expanding it, or looking at, make sure you have a good foundation, it is important to look at the TE varieties of RSVP. I think you'll find that they bring a lot to the table.
I would second Lou's comment, because right now the only active work on and use of RSVP is TE, not HintSurf.
And with that, we're going to move on to microburst. Peng, if you would come to the mic while I find your slides.
Can you hear me?
Yes. Just make sure to say next when you're ready for the next slide. Please go ahead.
Okay, thank you. This is a draft about microburst, and I'm Dongpeng Du from China Mobile. And next, please. It is the second version, and we get some feedback and make some modifications. First, we change the statement that the large-scale SP network is not in scope, and it's because DETNET is scope for single administrative domain, which could be small or large. And we also change the status to the informational, because our key issue is not an implementation of a queuing mechanism, but is a new exploration to provide this low latency service. And we add some explanation about the motivation and the way to decrease the microburst. Several new sections are added. Next, please.
One comment about, I'm sorry for the delay. One comment on the slide. You say DETNET is scoped to single administrative domain. It also can support a closed group of administrative control. So it could include cooperating administrative domains. So I think your comment there, that sub-bullet, is not aligned with our charter. So just be aware of that.
Okay, I will correct it. Thank you.
Thank you.
This page about what we want to solve in this draft. In our opinion, currently the TSN mechanism are too complicated to deploy in large-scale SP networks. We have analysis many problems. The conclusion, our conclusion is that nowadays we are short of a common and a simple method to provide this low latency service in large-scale SP networks. Our method mentioned in the draft show a potential solution that is both simple and scalable. Meanwhile, it does not need type synchronization. We think that perhaps it can benefit some low latency service providing in large-scale SP networks. Next page, please. This page about the mechanism in our draft. We have several preconditions. The first one is that critical traffic in the network should have a higher priority. And the second is that have enough bandwidth reserved so that there should be enough bandwidth for them on the interface. So we think that there should no burst in the network. And in this case, the main problem is to decrease the microburst. In our mechanism, we do this flow shipping on the edge, and on the intermediate nodes, we do the per interface aggregated shipping. We change the regular behavior on the router it is to say that the router forwarding all the traffic as soon as possible. In our mechanism, we use the shaping method in the TSN so that the traffic will be forwarded in an ordered way. Next page, please. We also give some analysis about the proposed method. When we comparing into the traditional IP forwarding with the priority in a relatively light-loaded network, our mechanism can offer a better forwarding for the low latency traffic with less microburst. And of course, we have some cost, the cost of shipping on the edge and keeping the shipping result on the intermediate nodes. Comparing the TSN mechanism, our mechanism is simpler and more scalable. Of course, we have some disadvantage. It's about the uncertainty. If we think that in our mechanism, uncertainty perhaps is higher. Okay, when the uncertainty is higher, perhaps some of the NAT use case cannot be supported in our mechanism. Next page, please. This page is about the work at the next step. We will try to find whether some of the DETNET use case can be supported in certain conditions. We think that, for example, in a network that the critical traffic is not too much, or the low latency traffic is not that critical, and perhaps at the first step, the low latency traffic not that critical would appear in the large scale SP network first. And we also think about to do this approximate evaluation of the uncertainty. We need to check whether the mechanism we can work for those low latency traffic that are not that critical. And we think that the packet replication and elimination method in TSN can help, because in our mechanism, perhaps we cannot ensure that 100% lossless. This packet replication and elimination perhaps help to recover some packets that lost in the network. And this is the last page, I think. If you have any problem, any question, you can talk now.
Thank you.
Thank you.
David, can you go ahead?
Yeah, so looking at the description of this, the approach looks a lot like diffserv, where the flows are individually policed at the edge, and then there's flow aggregate traffic conditioning in the core. The scalability comments are definitely on the mark, because that was one of the reasons that diffserv was designed the way it is. I'd encourage the authors to take a look at diffserv framework. That'd be RFC 2475 as a place to start.
Thank you. I will.
Any other questions, comments? Yeah, personally, I think this is interesting work, and we look forward to seeing how it evolves. I don't know if there's any other comments. If there's not, we're going to move on. Thank you very much.
Thank you.
I think Yakov is up next.
I think so as well. How's my audio?
It's okay. Please go ahead. Just say next when you're ready.
I understand that that's what has to be done. maybe one day Meetecho will have a button for us to push to move someone else's slides. Hi, everyone. Yaakov Stein. It's nice to be back in the IETF after a long time. Next slide, please. The reason I haven't been coming to the IETF for a long time is I've been wasting my time with 5G X-Haul transport. And I really could use this time to plug a book which just came out, but I won't do so. There are problems having to do with delays, I'm sure you all know, when doing backhaul of mobile, and it's gotten much worse in 5G. And people have thought that perhaps TSN or DETNET mechanisms can be adapted to solve this problem. And it turns out it doesn't work very well. In particular, I'm talking about QBV, which I realize is not a DETNET, it's more of a TSN approach, but I have to define my first line here. The mechanism I'm talking about is for what I call a time-sensitive packet flow, where I mean by time-sensitive simply that the packets have to be delivered within only a little bit more than the physically possible minimal time to get through the network. And when you try to use mechanisms that do time gating, it turns out that they don't scale, and if you actually try to give an upper bound, the upper bound is much higher than what is physically possible. And if you don't plan it correctly, and it's almost impossible to plan it correctly, the efficiency on the line goes down. And we're wondering if there is a mechanism that doesn't suffer from all of these problems. And it's interesting, by the way, that the 802.1 people themselves, the TSN people, in their CM document for X-Haul, recommend frame preemption, but don't recommend their own mechanism for this case. And which I think is basically because it doesn't scale very well. Can I have the next slide, please? Just before I introduce what I want to talk about, I just want to give a model for the forwarder, which from now on I'll call router, although it could be a switch, an SDN switch, an MPLS, LSR, whatever you want. But basically, I'm talking about a forwarding device which has two parts. Forwarding logic, which takes the packet and decides which output port it has to go to, and scheduling logic, which decides which packet of all those packets that have to be transmitted over the output port should be first. And I just want to mention that when you think about it in terms of segment routing and TSN or DETNET, rather than saying which port and which packet to send over that port, you can think of it as where to send a packet and when to send a packet. In other words, forwarding is basically saying, given this packet that just arrived, where should I send it? And scheduling says, when should I send it? And when means something when you have your network elements all synced up to a common clock. Next, please. So what am I proposing? I'm proposing an alternative to using QBV and similar mechanisms that relies on using a stack data structure added to the packet, in the packet headers. I'll mention in a moment what has to be in that stack. There are two options. One is only for the scheduling problem, one's both for the forwarding and the scheduling problem. And the nice thing about this alternative is that it can be optimized in a scalable way. Its configuration can be adapted. In other words, you can add a new flow without having to start touching a lot of network elements, a lot of routers in the network, during which time you'll have inconsistencies and you might have packets either be lost or fail to meet their deadlines. And it can get down to very, very close to the physical delay. And the mechanism using a stack has sort of an analogy with segment routing. I spoke about this yesterday in Spring, and there some people said it's not really segment routing. However, I want to claim that it's a kind of, it's analogous to segment routing. And we'll see why in a moment. Next slide, please. Okay, so to explain to you why I need a stack, let's talk about two known ways to reduce end-to-end propagation delay without doing gating and things of that sort. One is called longest in system, in which you insert into a packet its birth time, that is the time either it leaves the host or enters the network, and you prioritize packets based on the birth time. Earlier packets get sent first, but obviously this is suboptimal because a packet which has been a long time in the system but doesn't have a very tight budget would be prioritized over a packet which actually is almost has its budget used up, but it hasn't been that long in the system. So you might decide, let's use what's called earliest deadline first, or EDF, and that simply puts the packet's deadline, the absolute time that it's supposed to reach the other end of the network or the final host. And that sounds better. It is better. However, that obviously prioritizes packets with an earlier final deadline in each router along the way, without knowing how far it is from this router to the final destination. So you might have a case where you are prioritizing a packet which just has one more hop to go over another packet which has which looks like it has more time, but actually has a large number of routers yet to traverse. So both LIS and EDF and many other variations where you put one time into the packet aren't good enough. Next slide, please. So the idea is to put a stack of deadlines. When I say a stack, I simply mean a list where you see the top of stack and you pop it each time, and that stack element has the absolute time that the packet should leave the present router. So for each router you traverse, you pop the top of the stack, you look at that time, and you do some kind of scheduling, which might be EDF or just in time or something I call PEDF, look at the draft, or any other mechanism. And of course, you need some mechanism for figuring out these deadlines. I'm going to show you one in the next slide, which I mentioned in the draft, but certainly not the only mechanism. And I refer to other ones in the draft as well.
3 minutes.
Okay. Of course, this requires something more complex in the router than a simple FIFO queue per QoS like is normally done in a router or a switch. However, I think it's less complex than using time-sensitive gates, time scheduling gates. Next slide, please. And why do I say it is analogous to segment routing? Because if I'm already putting a stack which has an entry for every router to be traversed into the packet, I might as well combine it with segment routing and have both the forwarding decisions and the scheduling decisions in the same stack. In other words, I can put a stack in where every entry in the stack has two sub-entries, one a forwarding sub-entry, basically where do you send the packet, and one a scheduling sub-entry, which says when to send the packet. So when you do this, you pop each router pops the top of stack and knows both where to send and when to send the packet. This can be combined with best effort traffic, with strict priority, and you can even have several priorities of time-sensitive packets. Next slide, please. Here's a simple example to give you the idea why these numbers are what they are. You can see in the draft. However, the idea is the host, in this case, I'm using it like in segment routing rather than like in source routing. So you actually see the header which is being inserted only after the first router, and it has the number of entries as the number of routers -1. But basically, you will see the stack there, the SRTSN stack, if you're doing both, where you have both the forwarding sub-entry and the scheduling sub-entry. And each time one is popped until you get to the final one. And you can even save a bit by having a special code for bottom of stack rather than wasting a bit. But we don't really have to go into that right now. Next slide, please. I realize I only have 1 minute. I was asked to talk a little bit about how much room this takes. If you're thinking of 128-bit IPv6 addresses and 64-bit timestamps, this would sound like it would take a tremendous amount of room, but not so. You can actually make do with many fewer bits. Actually, I even give you 1 extra bit here, because if you do that trick I mentioned before about the bottom of stack, you don't need that +1 at the end. But you actually, in many cases, for the kinds of networks where this is important, where you have several hundred routers and the maximum amount of time that a packet can go through the network is on the order of milliseconds, this can end up being 16 bits or maybe 32 bits if you're really going to squander them, which means that between 4 and 8 hops only require as much room as a single IPv6 address. Next slide, please. And to sum up, what I'm asking from this working group, and I asked something similar to this Spring working group, and I was going to ask PCE as well, but they didn't get me into their schedule, is where should this work be done? It is similar, it has elements of segment routing, it has elements of time sensitivity of the DETNET variety, and of course it requires an optimization algorithm. And by the way, it was interesting to hear just before about RSVP. I also have a non-centralized mechanism where you don't have to do measurement of the link delays ahead of time, but rather send an RSVP-like packet ahead of actually several of them and measure and acquire timestamps and sort of measure the delays as you go. But simply I'm asking for the chairs to coordinate where and if they want this work to progress, and of course if there's interest in this work at all. That's it.
Okay, you didn't leave time for questions because we do have one more slot and we're rapidly running out of time. We'll take the action to coordinate, so absolutely. And it seems like there's some interest because we've got good discussion on the list, which is always nice to see on a new draft. With that, we're going to move to the last presenter. Excuse me. And, by the way, thank you, Jakob, for showing back up.
Hello, could you hear me?
We hear you just fine, and your slides are up, so please proceed. Thank you.
Thank you. This is Joanna speaking. I'm going to introduce the problem statement about queuing magnesium with multiple cyclic buffer. I have submitted the draft. Next, please. The previous experts has introduced the method of guarantee deterministic services from different angles. This draft focus on the queuing mechanism of cyclic queue and forwarding to guarantee the end-to-end bounded latency. The bounded latency draft have already described the requirement about it. For a given DETNET class of services, there are a set of 2 or more buffers provided under the output queue layer. Next, please. The IEEE 802.1 QCH has defined the 2 buffer self queue, 2 buffer per output. As the left finger show, all nodes keep the same cycle starting time. The packets sent by upstream node and cycle X must be received by node B at the same cycle. In a cycle X, node A sends all packets in the buffer to node B. In the same cycle X, node B uses a buffer to accumulate all packets from A. At the same time, the node B sends out the packet that have already been buffered in cycle X minus 1. In the next cycle, X plus 1, the node B will send out all the packets that are received from node A in cycle X. Therefore, if the packet traverses H hops, the maximum latency is H plus 1 times TC. What is TC? TC is the buffer of a cycle, and the minimum latency is h minus 1 times TC. The jitter bounded is 2 times TC. As the gray square, it's the data time in circle X, which is used to identify different cycle. The link propagation delay should be observed by a cycle. Next, please. The problem statement of two buffer CQF is presented. The 3-point disadvantage. First, the data time waste bandwidth resource. For example, the data time is the gray square, is the sum of link delay, output delay, preemption delay, and the processing delay. This buffer cannot be used to send packets with the deterministic services. So this mechanism prohibits the deployment with long link because the link propagation delay must be smaller than TC. So if the link is longer, the TC is bigger, the bounded latency is bigger, and the jitter is also higher. The last advantage is that the node B will receive the last packets in cycle X from node A, and also receive the first packet from cycle X, X plus 1 from node A. So the cycle ambiguity easily occur because the variation in link delay and output delay. Next, please. So a keying mechanism with multiple cyclic buffer is proposed. The DETNET bounded latency describes the requirement for CQF with more buffer. The multi-cyclic queue and forwarding paper also recommended to support long link and good latency and bandwidth utilization. So this way, decouple the link propagation delay and TC. For example, without sacrificing the bandwidth utilization, TC can be used with arbitrary link length, and the number of buffer can be flexible site. To solve the problem of cycle ambiguity, a cycle label can be put in packet. This label identifies which cycle the packet belongs with. The packet in different cycle can carry different cycle label. There can be multiple ways to map cycle label in a packet to local cycle buffer. For example, the node B may receive the packets from different upstream node that carry different cycle label, and put the packet into the local label. So he swamps to the upstream label to the local label. Maybe there are different mechanisms to achieve them. Next, please. Welcome to review and contribute. Content and co-author are also welcome. Thank you. Hello, Chair.
Yes. Hello?
Hello.
Do you have a question? Or, okay. Well, thank you very much for the presentation. I'm not sure if we see any questions. Actually see David is unmuted. David, do you want to make a comment?
Yeah, let me see if I can choose my words carefully here. There's been some extensive behind-the-scenes discussion between myself, the chairs, and with the ADs watching about this draft. The advice I would give to the authors is to split the mechanism away from the location of the bits. And then I think the crucial question to the DETNet working group is whether the problem that the authors propose to solve is something that the DETNet work group wants to take on, in which case a plausible path forward would be to work on the mechanism here and then go look for the bits elsewhere. And I can think of at least 4 places where one might be able to find bits.
Torlis,
Thank you.
How is this, so David, how is this different from Yakov's draft with respect to queuing mechanism versus encapsulation?
I'm not sure I want to split that hair. I'll just observe that both those drafts came to DETNet for DETNet to figure out whether the scope of what the work group wants to work on includes the problems that Yakov and this draft propose to solve.
Right. So from my perspective, certainly the normative thing that we require would be an encapsulation for the interoperability, right? And I think that applies both to Yakov and our draft. And you know, I can just observe that would be the similar type of, you know, encapsulation that was done in support of pre-auth in DETNet.
Allow me to suggest you get the cart and the horse in the right order. If you have a defined mechanism, it then becomes possible to go define the encaps. And in this particular case, I can think of multiple encaps that will work.
Right, and the mechanisms are defined, like TSN. They may not have been defined in the DETNet working group, but the encapsulations, you know, in the same way as pre-auth, right? Where was pre-auth defined, and why did DETNet take on the encapsulation MPLS for it?
All right, we have Yakov in queue, Stuart in queue, and I'll point out we're over time. They usually let us run a few minutes over, but we will have a hard stop when Meet Echo says that we're done. So we'll keep going as long as we can, but just be aware we are over. Yakov?
I'll be really, really quick. Just as a response to what Terla said. I am not at this point recommending any particular encapsulation. I'm bringing up an issue. I think this issue is a valid one. It's one of the problems that I mentioned also, that all kinds of gating have this problem that they have to absorb the amount of time between the switches. And I think that the right thing to do is, if the mechanism actually can be proven to be efficient, is you'll have to define either a universal encapsulation, which is in addition to everything, or find a way to stick the bits in. And as was mentioned before, there are several different places you can put it.
Stuart?
Well, it seems to me that, it seems to me that this is definitely a problem that DETNet has the largest interest in, it being the working group that's working on the most critical form of time-related communications. And so I think this is really the place to at least start this piece of work. If we decide that we need to export it to a specialist encapsulation group, then that's fine. But I think this working group is the working group that needs to own this set of problems associated with getting packets to the right place in the right time.
Okay, thank you. I'll point out that to date, we as a working group have only taken on informational documents related to queuing, not standards track, because that's outside our current charter. And more than that, the transport area typically owns queuing mechanisms. I don't know of any case where a queuing mechanism has been defined in the routing area. The definition of that, though, is not outside the scope of the IETF, and if the ADs and the transport area agree that the right place for it to be done is DETNet, we'll follow. But we are being very careful as chairs to stay within our charter and to coordinate with the transport area on the definition of new queuing mechanisms. Referencing existing queuing mechanisms and how they operate with DETNet, and whether they need special bits on the wire, I believe that is in scope. That is within the discussion. It's the queuing part that's not. I'm going to go to David out of queue just because we might get cut off. And if we're still going, we'll come back to Torlis and Stuart. So David, next.
Wearing my transfer area working group hat, as we're likely to be one of the places where the bit hunting goes on, the expertise on cyclic queuing is very clearly in DETNet, not in the transport area working group. I'm comfortable going looking for bits if the mechanism is defined here. I'm not comfortable being the primary venue for defining the mechanism.
Okay, thank you. I mean, and we can follow up with ADs on that comment. So thank you. Torlis? He dropped himself. Stuart?
So I'm pleased to hear that from David. I would have been worried if it had gone to transport and then died, but because I think this is really important, and because it's important to us, we need to work on it.
Uma?
Hi. So thanks, Chair. So I think my opinion is basically the problems DETNet has been talking over a period of time with respect to bounded latency and also the jitter case. This draft need to be solved in DETNet. And also it's not, this is DETNet is more focused on PE to PE case, not end-to-end, so to speak, from what TSV working group is doing. So I think this has to be done in DETNet to the associated problems and use cases have been discussed for many years here.
Okay, Stuart, are you still in queue? I assume you're out. And all right, well, thank you all for the discussion. As I mentioned before, a big issue with queuing is our charter, and that queuing isn't done in the routing area traditionally in the IETF. But we'll work to find a home, and so we'll work with the transport area chairs, which includes David, and also with the area directors who the ISG says where work goes. So we'll work with them on that. And
can I just jump in with a question there, not about the queuing, but if I observe Yakov's draft, which I find very interesting from the perspective of actually, in contradiction what some people in Spring thought, I think is an ideal case of exploiting segment routing, whether it's MPLS or V6. We haven't, done SR as a forwarding plane in DETNet. Am I the only one that sees that as a gap?
That's a question so SR has been raised a few times in the working group. We've said we're going to coordinate with the SR chairs, and we've been talking with them over the last 2 or 3 IETFs. Privately, we've said to them, it's time we have to make a call as to which working group owns this. So we've said to them that we're happy to do it in DETNet, but it's also, that's their forwarding technology. So we want to coordinate with them, and we'll let you know which working group that work should go to.
Yeah, from my experience with multicast and MPLS or so, I think that's an interesting discussion what to do best to get the best results. So yeah, thank you.
All right, appreciate everyone staying over. We're going to end the meeting now, and really appreciate the contribution and look forward to further discussion on the list. Thank you all so much for participating.